A young child rides on a merry-go-round at a carnival. The merry-go-round has a radius of 5 meters and completes one revolution every 12 seconds. The parent of the young child stands and watches at the point P, which we can see just here, exactly 3 meters away from point B. So this is 3, and we know this radius is 5. The ride begins at point B when the child is closest to the parent, and the merry-go-round goes in an anti-clockwise direction, so we know it's going around this way, at a constant speed. At any point in time, point C is the position of the child on the merry-go-round. So what do we got? Let t be the number of seconds the ride's been in progress. S is PC, as we can see on the diagram, and theta is this angle. Show that d theta dt is pi by 6. Well, we know that we get one revolution in 12 seconds. So that means 2 pi radians in 12 seconds. So the speed, d theta dt, is going to be 1 revolution divided by 12 seconds, which is 2 pi radians divided by 12, which is pi by 6 if we were in radians per second. We now want to show that s squared is equal to 89 minus 80 cos theta. So let's use the cosine rule. We know this length is 5, and we know that this length here is 8. So s squared is going to be 8 squared plus 5 squared, take away 2 times 5 times 8 times the cosine of theta. So s squared is going to be 64, add 25, take away 80 cos theta, and 64 add 25 is 89. So s squared is 89, take away 80 cos theta. So by differentiating, s squared is 89 minus 80 cos theta implicitly with respect to time, determine, correct to the nearest 0.01 meters per second, the rate at which the child is moving away from the parent when the ride has been in progress for 4 seconds. So we're differentiating with respect to time, so s squared will become 2s ds dt, and it's ds dt that we're interested in finding here. The 89, of course, will disappear, and cos goes to negative sine, so this would be 80 sine theta d theta dt. But of course we know that d theta dt is pi by 6. So we could divide by 2 here, and we get s ds dt is 40 sine theta times pi by 6. So s ds dt is going to be, well, 40 over 6 is 20 over 3, so 20 pi by 3 sine theta. Now, if the ride starts here, theta initially is 0. After 4 seconds, it will be 4 pi by 6, or 2 pi by 3. So when t equals 4, we have that theta is 2 pi by 3. And of course, we can also work out s. The cosine of 2 pi by 3 is negative a half. So we'll have s squared is 89, add 40. So s squared, so it's going to be the square root of 129. So ds dt is going to be 20 pi by 3 sine 2 pi by 3 divided by the square root of 129. So we just need to calculate that. So we get 20 pi divided by 3 multiplied by the sine of 2 pi divided by 3 all over the square root of 129. That gives us 1.60 meters per second. So finally, we want to determine the value for cos theta when the rate of ds dt is the maximum. So from above, we have that ds dt is going to be 20 pi by 3 sine theta over s, which of course is the square root of 89 minus 80 cos theta. So we just want to find the maximum of that. Now, how are we going to do that? Probably, I think we should just graph it. So let's give that a go. So we're going to graph and table, clear out anything we have, and let's input this function. So get the keyboard, and I've got 20 pi divided by 3 multiplied by sine of theta, in this case we'll use x, all over the square root of 89, take away 80 cos x. Okay, let's see what happens if we graph that. We need to be in radians, obviously. Okay, so we can see the graph that we have here, and we'd like this maximum. So analysis gsolve, let's go for the max, and we can see that's 0.89566. So with the cas, we get theta is equal to 0.8956648, and it was the value of cos theta that we wanted, so we just need cos of that. Let's go back to main, clear anything we've got, make sure we're in radians, and we want the cosine of 0.8956648, and that's 0.625. Correct to 3 decimal places.